In this highlight video, we're going to talk about functional groups. We will learn to identify functional groups, and then once we can do that, we will then further categorize those functional groups based upon their physical properties, and this will lead to an understanding about the reactivity of these functional groups. So, what are functional groups? Functional groups are reactive units which are composed of either a single atom or groups of atoms. And these have characteristic chemical and physical properties. So for example, we could draw this molecule here. We've learned already that this is ethanol. The functional group in ethanol is an alcohol. So if we take an alcohol and we put it into another molecule, this one would be called pentanol. Even though these two molecules are different, the alcohol will have the same properties and same reactivities in both molecules. So that's where we will often use this generalized formula where we put an R and then the alcohol. So the R equals some generic organic portion of the molecule. So why are functional groups important? Well, when we look at organic molecules, we will know that the functional groups are essentially the business part of the molecule. That's the part that's going to be reactive. That's the part that's going to influence the bonding, the shape, the physical properties, the naming, all of these things about the molecule. So when we look at a new molecule that we haven't seen before, we'll always try to focus in on what the functional group is. Further, you'll notice that as you look through the textbook, many of the chapters are organized based upon their functional group. So the functional group organization allows us or gives us the order in which we do our teaching. We can classify or categorize our functional groups into three different categories. The first category that we'll look at are the hydrocarbon functional groups. So these are molecules or groups that have only carbons and hydrogens. The next group will be functional groups that have a more electronegative atom bonded to a carbon through a sigma bond. So here we have CZ. Z will be more electronegative than carbon, so it will pull a delta minus towards it, leaving carbon with a delta plus, and this will influence the reactivity of these types of groups. The final category of functional groups are those that contain this carbon-oxygen double bond. This is referred to as a carbonyl group, and these are very important in biology and in biochemistry. Our first group are the hydrocarbon groups. We've looked at some of these before. The first group are the alkanes. Alkanes have just carbon and hydrogen and only single bonds. These are really what I think about as being an organic molecule in the absence of functional groups. Okay, this is kind of the basic organic molecule without anything else attached. Our first real functional group then are the alkenes. Alkenes have carbon-carbon double bonds. We've seen this molecule before. This is ethene. So carbon-carbon double bonds. The next group are the alkynes. Carbon-carbon triple bonds. This is ethine. Right? Remember there was another name for this one that we talked about before. So this is also called acetylene. Acetylene is really the common name. Ethine is going to be a systematic name, and we'll learn how to do systematic naming pretty soon. The last group of hydrocarbons are called the aromatic compounds, and they have this general type of formula where we have a six-membered ring and alternating double bonds. The simplest of those molecules is this one here. This is called benzene. Remember that each of these joints here have a hydrogen attached. And aromatic compounds have some unusual properties. If this is attached to something else, then this is often called a phenyl group. We can put several types of electronegative atoms onto carbons. The first of these groups are halides. If we put either a fluorine, chlorine, bromine, or iodine onto a carbon, we generate an alkyl halide. Remember that these halides are more electronegative than carbon, so like this one here, we'd have a delta minus on the bromine, leaving a delta plus on the carbon. We already talked about the alcohols. They have an OH. And ether is a molecule that replaces the H of the OH with another carbon. So ethers have this carbon-oxygen-carbon arrangement. If we put a nitrogen instead of an oxygen, we can generate an amine. And amines can either have 1, 2, or 3 carbons attached. Okay, so like this one over here has only 1 carbon. If we replace those hydrogens with other carbons, we can either replace one or both and they'll still be called amines. If we replace the oxygen of the alcohol with a sulfur, then we get a thiol, so SH. And if we replace the H of the thiol with another carbon, we get carbon, sulfur, carbon. This is called a sulfide. All right, so this is also sometimes called a thioether because it's just like the ether up here, but it has a sulfur instead of an oxygen. All right, the last group is a really big group of functional groups here, and these are the ones that have this carbon-oxygen double bond, the carbonyl group. Now, the generic form of this is really R carbonyl with some Z, with some other group. So they're all going to be different based upon what this Z group is. So here we have the simplest of these. That Z group is a hydrogen. So we have the carbonyl with a hydrogen onto it. This is called an aldehyde. The simplest of the aldehydes has 2 hydrogens on it. This one I think we wrote before is formaldehyde. All right, it's used for preserving things. You might have smelled it before in the biology lab. If both of the atoms connected to the carbonyl are both carbons, then we get what's called a ketone. So if we replace the H of the aldehyde with another carbon, we get a ketone. All right, if we have this example right here, this is referred to as acetone. This is a common solvent that is in fingernail polish removal. If we replace the aldehyde H with an OH, we've seen this before, this is called a carboxylic acid. And so this simple one is acetic acid. Okay, if we have condensed structures, I left that out. A confusing one for aldehydes is that we write this CHO. So if you see that, this refers to this functional group here. Right? So carboxylic acids are commonly written CO2H, or another way, which I don't really like, but you sometimes see it, is COOH. All right, so let's keep going. If we look at the carboxylic acid and we remove this H and we put on another carbon, then we generate an ester. If we remove the H of the aldehyde at the top and we put a nitrogen on it, right, we get an amide. And like the amine that we saw on the previous slide, this amide can either have 2 H's here, or one or both of those H's can be replaced with carbons. Okay, amides are really important in biology because an amide bond is the type of bond that links together amino acids in proteins and enzymes. The last of the carbonyl groups are called the acid chlorides, and this has the carbonyl with some halogen, or not any halogen, but a chlorine attached, and we'll find later that these are very reactive. So I know this is a lot of functional groups. Basically, we're learning the language of organic chemistry right now, and so amongst these functional groups, you basically just have to memorize them. You can make flashcards, you can practice them, but without knowing, you won't know anything about the properties of the molecule, you won't know how to name them, or anything else. So recognizing functional groups is a very important and basic part of this course. So let's look at this really complicated molecule called laulimalide. This is a molecule that when I was doing research, we isolated from a marine sponge, and with collaborators, we found that this molecule has some very exciting anti-cancer activity. So let's look at the functional groups in this molecule. So what about this molecule, this functional group right here? Okay, so this is got the OH. This is an alcohol, right? Are there any other alcohols in the molecule? Well, here's another alcohol right here. Okay, so there's 2 alcohols in the molecule. So do you see any other functional groups in this molecule? All right, well, we have, what's this right here? Okay, this is an alkene, carbon-carbon double bond. Are there more alkenes? Yeah, there's one here, there's one here, there's one here, and there's another one over here. So there are, in fact, 4 alkenes in laulimalide. Are there any other functional groups? Yes, there are. What would this be? Okay, it has an oxygen and it has 2 carbons attached. Right, so this would be called an ether. Are there any other ethers? Okay, here's an ether. What about this one right here? Is this an ether? Well, it looks kind of like one. It has 2 carbons attached to each other, but one of those carbons is this carbonyl group. So this isn't really an ether, but let's see, what color should we use here? This, if we go all the way to this carbon, to here, this would be called an ester. All right, are there any other functional groups? Well, what about this one over here? All right, so this really has an oxygen. If we look at what that oxygen is connected to, it's connected to 2 carbons. All right, so this is another ether. Okay, so in laulimalide, we have alkenes, we have alcohols, we have ethers, and we have an ester. Let's try one more of these, and then you can do some on your own. Tetracycline is an important antibiotic. Maybe you've heard about it before. So let's look at some of the functional groups in tetracycline. All right, so what's the first you see? If we start in the upper left, what about this? This is an alcohol, right? Here's another alcohol. Here's yet another alcohol. Are there any more? Yeah, here's one. And here's another one. Look at that. There's 5 alcohols in tetracycline. What's this group? We'll put the 2 groups attached to it. Right here, it has a carbonyl, and it has a carbon here and another carbon here. Right, so this is ketone. All right, are there other ketones? Well, here's one right here. What about here? No, that has one carbon attached, but the other side is actually a nitrogen. So instead of a ketone, this group is called an amide. All right, so what else do we have? What about this one down here? This is an amine. And I think the last thing that we could draw in here as a functional group would be this group right here. Well, not only that, this would be the aromatic group. And right here and right here, both of these, what are these carbon-carbon double bonds? So these are alkenes. All right, that one and this one. So there is a lot of functional groups in tetracycline. All right, so let's start with something a little bit easier though. So try these problems.